Everybody, welcome to a new lecture, and in this we will be covering a topic called as non-overlapping intervals. So what problem is this? So basically it is, we have an intervals array, so given an array of intervals where the intervals I is start I and end I. So we know it's a vector of vector from this line, and what the question is asking is, it's basically to return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. So minimum number of intervals that we need to remove so that the rest of the intervals are non-overlapping in nature. So what does that mean, non-overlapping in nature? So for example, if there is an interval like that is one, say that has the start time from 1 to 5, and if there is an interval that has a start time from 2 to 4, so that 2 to 4 is completely overlapping to a bigger interval, right, 1 to 5, so that is overlapping. And over here there is a note as well. The note is over here which says that if there is a point which is starting and ending at the same point, so suppose it's this particular interval is starting at 2 and this particular interval is starting ending at 2, so this is not considered as overlapping in this particular question. So they are non-overlapping in nature. So let's go through the examples here. So from the examples we can see that we've got this interval that starts at 1, ends at 2, starts at 2, ends at 3, starts at 3, and ends at 4, and then we've got this particular interval here that starts at 1 and ends at 3. So what we can observe from here is that this can be removed and the rest of the intervals are non-overlapping, right? So because there's no overlapping here, if we just remove this, and this particular interval is overlapping these two intervals over here. So now the question arises that whether we can just go ahead and remove the first two intervals. Even these two intervals at a point are non-overlapping in nature, right? So that's the reason the question specifically asks for minimum number of intervals that is needed to remove so that the rest of the intervals are non-overlapping. Alright, so now what we've got over here is what we've got a vector of vector, simply because we've got an array of intervals where each intervals is like having another array, and that array has two elements, start time and end time, right? So how do I solve this particular problem? So let's sort this thing. We've got to manipulate this interval. So that is for sure, right? We've got to manipulate this interval in such a way that we are able to remove the minimum number of overlapping intervals. So to do that, it's easier to sort it out. So let's sort out the intervals dot begin and intervals dot end, right? So over here, if we see, we are sorting it based on the start time, right? We are doing that start time. Now let's traverse through that loop, and what we see is, let us have the first element as, let's consider that particular first element as non-overlapping in nature, because obviously the first element, if we see over here, right, 1 comma 2, let's consider that as an interval which is not overlapping, because we have not traversed, or we do not have any other interval at sight. So we can name it in such a way, like we can say int last non-overlapping index. We can say that as 0 and we can say that as 0, and we can also say that the response, or we can say, I'll just name it better. We should not name a variable so big in practice while doing projects, but since for better understanding I'm just writing it down here, it should be short in value, applying this knowledge in some real-time projects. So now we can say that this is the minimum interval to be removed, minimum intervals remove, right? And we can initialize that as 0 as well. And now since we have already made sure that the first particular element is non-overlapping in nature, we can start with the second element. So that's the index I. So we can say int I is equal to 1, which will be traversed until the last element of the intervals I plus plus. So what do I have to check here? So I will check that if the current interval, right, that I'm checking start time, if that is less than, right, if that is less than, for example, if someone wants to end something at 3 o'clock, but another thing if that's starting at 2:30, so that is overlapping in nature, right? So if that particular start time is less, then the last non-overlapping indexes, I'll just copy this so that I don't have to write it again. If that is less, then the end time of the last non-overlapping index, that means we have something overlapping in nature. That means there is an overlapping here. So if the interpreter goes inside this if condition, we can say that overlapping exists, right? We can say that because the start time of something is less than the ending time of the previous index. So something that is supposed to end at 3 o'clock, right, and there's another element, there's another interval, another job that is starting at 2:30, so that is overlapping in nature, right, by half an hour. So that is the case that we are trying to cover over here, and that means there's an overlapping that is existing. So we can increase this minimum intervals to remove. We can just increase the pointer of that. So I will copy this as well and paste it, and we can just say if that is not the case, so we can just initialize the last reinitialize the last non-overlapping index to the index I. And that means over here, if this reaches the else condition, that means there is no overlapping. Yep. And that will traverse through the entire loop, and then we can just return the minimum intervals to remove, and that's it. So now if we run it, let's see, I hope there's no issues. We have the issue here that there's no colon here. And intervals, it's intervals, not intervals, all good. So now we've got all three cases that are passed. But do you think, is this the solution? Right? Is this the solution? I don't think so. Let's try to submit it. If we submit this, I don't think it will pass all cases. Why it will not pass all cases? See, this is the wrong answer. The reason is we need to remove the minimum number of intervals. Over here, if suppose the interval that we are removing, right, right now we are considering the last non-overlapping index as the previous index. But what if the current index end time is smaller than the previous interval's end time, right? So if the current index over here end time, if it is smaller, that means we can accommodate more number of intervals, right? If some event is starting from 2:30 to 2:35, right, so we can have some intervals that are starting from 2:35, right, and which may go on. But if suppose another event that is starting at 2:30 if that is ending at 3 o'clock, so we cannot have intervals that are ending at 2:35, 2:40, 2:45, right? So if the end time is less, so we can accommodate more number of intervals. And since we want to remove the minimum number of intervals, so we will try to have the intervals, so we'll try to accommodate more number of intervals over here. So what we will do over here is, if intervals I, so end time, the current interval that we are checking, if the end time of that is less than the intervals, that is having the last non-overlapping index anytime. If suppose that is, you know, if that end time is lesser, one second. So then I can say that we can remove the previous element and we can accommodate this particular interval, so that then the last non-overlapping index should be equivalent to I over here. Why? Because the end time of the current interval is less than the end time of the last non-overlapping index, and since we have the end time to be less over here, we can accommodate more number of intervals. If we are able to accommodate more number of intervals, then more number of intervals will go into this case, which are non-overlapping in nature, and this would be reduced. So now if we run this, now it should pass, and now when we submit this, this is also passing. Now you would say that since if the whole goal over here is basically to have the least end time as possible, why on earth are we sorting on the basis of the start time? It's because I didn't want it to have a comparator, and by default the first value of the sub vector is considered for comparison by the sort function. So that was the reason. So let's do it by the end time as well. So all we have to do is nothing. If you are sorting by end time, then we do not require this. All we have to do is just declare a comparator which is returning a boolean. Let's name that comparator CMP, which is basically expecting two vectors that are passed by reference, and A, and this is vector int and B. So we've got two vectors here, and then we are comparing the end time of those two intervals, and then if suppose A of 1 is less than B of 1, if this condition is true, then there is no swapping needed. But if suppose this condition fails, that means that the second element end time is lesser, then the swapping is required, and then all we have to do is just write it over here and give that as the parameter in the sort function. And I've removed this if condition, and now I will run it. I hope there is no runtime error. And yes, we're all good. And when I submit this as well, it should be going good. So now we have sorted with the help of end time as well, and even by start time. I will be pasting the code in the description, and thank you so much for watching.